Friends, so today we're gonna discuss two problems. Problem 1, number of enclaves and surrounded regions. Both of these questions are based on DFS and they have pretty much same code, but I will tell you how two different questions are related and how you can find out and correlate two different questions to write the same code and understand the logic. So let's start with this question. You are given a 2D array A. Each cell is 0, which represents a sea, or 1, which represents a land. Okay. A move consists of walking from one land square in 4 directionally to another land square or off the boundary of the grid. So you can either move in any of the 4 directionals from any square. Return the number of land squares in the grid for which we cannot move or walk off the boundary of the grid in any number of moves. So what you have to find out is actually a land piece from which you cannot move to the border. So I will tell you how. This is a land grid. I have drawn the grid. Now let's assume we are on this one. So irrespective of how many moves you can do, because one represents land. If you are here, you can move here, 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 but you cannot move out of this grid. But if you are on this block, you can move out of this grid. Let's assume you are on Iceland. This is water, and if you are on this island, you can move out of grid. But if you are on this island, you cannot move out of this grid because everywhere is surrounded by water. I hope you understand. But let's assume there is a 1 here also. Now you can move out of this grid. Okay, so you want to count how many squares square represent this land square, how many land square are there such that you cannot move out of this grid if you are standing on that square. Okay, so this is the question. Now how you can do it. The logic behind solving this question is you can pause the video and think about it also. But what you can easily do is you can iterate over the whole grid, and whenever you are on the boundary, you can process the DFS on all the ones which are on the boundary. So let's assume there is a 1 here. You are iterating through I and j. When you are on this I or this grid point, then you run a DFS because it's 1 and make all the ones which are connected to this one equal to 0, because all those ones will not be considered in the answer, because if you are standing on any one which is connected to this, so let's assume there is one here and there is a one here also. Now because if you are standing on this one or this one or this one or this one, all this one are connected to the boundary, so you can get out of this boundary to the boundary, and thus neither of these ones will be accounted in the final answer. So what you can easily do here is process all the boundary points, and if it's 1, run a DFS from that boundary point and make all the ones which is connected to this one through the DFS equal to 0. Then after that, let's assume we run the DFS and we come to this one, it will become 0, and make all of them 0. Now because this is not on the boundary, it will remain to be here as 1. Now after we process all the boundary points, we will again iterate over the whole array matrix and see how many ones are there. The count of 1 will tell us how many squares or blocks are there which are inside this matrix and cannot be reached towards the boundary. So I'll tell you more through the code. So this is the code. You can take the input of n and m, which is the size of the grid. I have made them global, and then iterate over the whole from I from 0 till n, j from 0 till m. If ai or the grid point is 1 and we are on the boundary, as you can see, I is equal to 0 and I is equal to n minus 1, all these conditions represent if you are on a boundary. Then we run a DFS. In the DFS, what we can do is, this is a pretty much standard code for DFS. If you go out of this bound of the boundary, then we just return, because we cannot do if we go out of bound of the matrix. Else, if we are in bound, we will make this aij equal to 0 because we have started our DFS when we encountered a 1. Then, because we are not out of bound of the matrix, we will first make this equal to 0 and then we run our DFS in all the 4 directions. So I'll tell you in the code. So let's assume we are on this grid point and we see this is 1. Now we run our DFS. So what we'll do is we will first make this equal to 0 and then for all its cardinal directions in 4 directions, which is this, this, this and this, we will run our DFS, which is I plus 1, I minus 1, j plus 1, j minus 1. And because as you can see, when we go in this direction, we have gone out of bound of the matrix. So we just return. For this case, though we are in the boundary, but this value turns out to be 0 and we do not want to process further because we are on the 0 only. We want to make all the ones which is connected to this one to 0. So we will only process further if we encounter another one. So that's what I've done. If we go out of bound or if we encountered any aij which is equal to 0, we just return. Else, which means that we have not gone out of bound and we have not encountered a 0, which means this coordinate on which we are is equal to 1. So we make this 1, and while after making this 1, we will run a DFS on all its cardinal direction in up, down, right, left, and then we return. After that, we will iterate over the whole matrix and count the total number of ones, and that's the answer. So that's the first question. Now moving down to the second question, you can understand the question first and then think about it. You are given a 2D board consisting of X and zeros. So now capture all the regions surrounded by X. So let's assume there are X's and zeros in the board. Now you have to capture all the region which is surrounded by X. So let's assume there is an army of X and there is an army of O's. So if some O's are surrounded by X's, then that will be captured by X. But as you can see, this O is not surrounded by X because it's on the boundary, and thus it will not be captured, but all these O's will be captured. So you have to print out the final matrix or return the final matrix. So you can pause the video and correlate how this question is related to the previous question we have discussed. Now, if you have seen, what we have to finally found here is any of the region or O's which are actually having 0 on the boundary will not get captured. How? I'll tell you. So let's assume there is a 0 here also, and there is a 0 here and there is a 0 here. Then all these zeros will be connected, 0, 0, 0, 0, 0. And all this 0 will not be totally covered by X's. So it means that any of the zeros which are having a grid point on the boundary will not get totally covered by X's. So then what we can do is we can do similar thing. We can iterate over the boundary of the grid and see whether we found a 0. If we found a 0, it means that it will not be get converted. Okay, so then what we can do is we can change this to a something new character, which let's assume to be hash. Then what we will do here is, if we correlate with this example, so if we encountered any of the ones which are on the boundary, we will make it hash, and all the connected components. So let's assume this is also equal to 1, and 1 means 0 in this case, and this will again become hash, and because this one is also connected, it will become hash, and everything which is connected to it will become hash, which actually tell us that all this component, all this ones are actually having a grid point at the boundary and they cannot be covered entirely by these zeros. Or else, now because everything in the hash defines that they will not get converted to X's because in the final result we have to show all those zeros will get converted to x's, but all those hashes will not convert to x's. Okay, so now what we will do here is we will run the bound, we will store the n and m size, then we will again do the same thing. We will see whether we are on the boundary point and whether the board value is equal to 0 or actually it's O. So whenever it's O on the boundary point, then only we'll run our DFS, and that's the same code which I've told you in the DFS again. We will check whether now we will break out of this loop, whether we go out of bound or we encountered an X, because we are only have to convert when we encountered a 0. If it's X or hash which we have seen, then we just return. Else what we will do is we will make this 0 converts to hash and then run a DFS in all the 4 cardinal directions. After doing this DFS, every of the 0 which have any grid point on the boundary will convert to hash. Some other zeros which are totally inside the X will remain to be 0, because when we run a DFS which are not having any grid point on the boundary, let's assume here, because all these zeros will not be in any of the DFS which we will run. This will eventually convert to hash, but because this all zeros are not on the grid on the boundary, they will remain to be 0 after all the DFS of the boundary points. Thus, we will again iterate over the whole matrix and we will check if we encountered an O, it means it will be captured in the final matrix, and thus we will convert it to hash. And all those board points which are hash, we will know that because they will remain to be 0, we will convert it back to 0, because in the final matrix which we have to return, we have to not return hash, we will have to return zeros and x's. So because if the 0 remain, which will not be converted, it will remain to be 0, and thus we will iterate over the whole matrix and remains it to x, and all the hashes we will convert back to zeros, and then we just return. I hope you understand both the two questions. If you still have any doubts, please mention down. This is a series of both DFS questions. If you understand and like my explanation, please hit the like button and subscribe to my channel. Till then, keep coding and take care. Bye.